Okay, your bell ringer, we have 2x squared minus 5x minus 3 equals 0. Does this work out nice?
Yeah.
Okay, so what's A, B, and C?
A's 2, B's -5, and C's 3, -3.
2, -5, -3. So I have x equals negative b. What am I going to put for negative b?
5.
Positive 5 plus or minus the square root.
25.
25, positive 25. 25 minus 4 times 2 times -3 all over 2 times 2, which
4.
is 4. Okay, how are we so far? All good? Filling in your A's, your B's, and your C's.
When are you supposed to know to use that in comparison to the X method?
Well, I told you to use quadratic formula. I have this feeling you could have used the X method on this. If you can use the X method, that's usually quicker. And the quickest way to look at the X method is actually doing the X. So A times C here would be -6 and B would be -5. So I can come up with numbers. If you can come up with these two numbers, you can use the X method. If you can't, you have to use quadratic formula. Today I wanted you just to practice quadratic formula just because we've had so much practice with that. But that's always your tester. Always do this first. If you come up with those numbers, then you can continue with the X method. If you can't, then you have to go to quadratic formula. So here I've got 25, and then I've got -8 times a -3, so that's a positive 24. So I have x equals 5 plus or minus the square root of 49 over 4. Everybody agree with me?
And the square root of 49 is 10.
Yep, so this one is a perfect square, so we're able to actually work this one out. So I get 5 plus or minus 7, all divided by 4, because the square root of 49 is 7.
And that's it.
So we can go one step further. We can go 5 plus 7, which is 12 over 4, which is 3. And then you can do 5 minus 7, which is -2 over 4, which is -1/2. So you get two answers. So that one you can just add and divide, add and divide. Or subtract and divide. Okay, so if it works out like this, you can keep going to get two numbers. But that's also another clue. If you're able to do the X method, then you're able to, this is always going to work out nicely. Okay? So today we're going to go on to complex numbers. And it looks to me like the rest of this week we're going to work on complex numbers and quadratic formula. And then your test in here is sketched out right now for next Thursday. So a week from this Thursday. Looks like we've got two more sections to learn, 1.5 and 1.7. So we're going to do 1.5 today and tomorrow. And I think if my memory serves me right, today's is really easy. So let me just get this. Okay, and I think everything we're doing today you have seen before, but I'll show it like it's the first time. Simple. Easy, easy, easy. Okay, yep, today's is not bad. So complex numbers are written like this. A plus BI. So what does the I stand for? Does anybody remember? Imaginary. So complex numbers are numbers that are not real. They're imaginary numbers. Does anybody remember how you get, bless you, an imaginary number?
Like a negative square.
Yep. So anytime I do the square root of a negative number, like the square root of -1 is equal to I. Because you can't do the square root of a negative number and get a real number. So the square root of -1 is equal to I. And does anybody remember what I squared equals? No? Okay, let's think this out with what I have already up here. If I squared this I and get I squared, and I squared this square root of negative 1, what would I get?
Or
Negative 1.
Negative 1. Yep. Very good. So these are 2 facts you need to know going forward. Today we're not going to, today all we're going to do is we're going to add and subtract, multiply, and then find the complex conjugate of them. Tomorrow we're going to divide and then use quadratic formula and get negative numbers. So today we're not going to be finding negative numbers, we're just going to be using them. Or not negative numbers, imaginary numbers. So have this written down. But for today, I want you to treat this like it's an x. So you can only combine imaginary numbers with imaginary numbers, just like only x's can combine with x's. So if I give you something like this, we're going to add together, I'll just do it over here. We're going to add 4 plus 7i plus 3 minus 2i. When you're adding, you don't need your parentheses, but it's going to be written like that, so that's why I want to show it to you. All you need to do is drop the parentheses, or think of them as not there, and combine like terms. So if I told you to think of the i's like x's, that means that the 4 and the 3 are going to go together, and that's going to be 7, because 4 plus 3 is 7. And then the 7i is going to go with the negative 2i, and I get plus 5i. And that's it for today. I mean, not for all of today, but that's it for the adding. That's it for today. I'm done now. That's it for adding. Adding is just combining like terms. If you think of the I like an X, you all know how to do it. Good with that? Yes, excellent. Okay, let's go through a subtraction one. When you subtract, it's going to be a little bit different, but not really. So let's do 3 minus 2i minus 4 plus 7i. What does your gut tell you to do first with the subtraction sign? Good. That's just like any polynomial we distribute. So we have 3 minus 2i minus 4 minus 7i. And then you guys finish this. Then it's just combining like terms. Did you get negative 1 minus 9i? Okay. Questions on adding and subtracting? Are we good with that? Let's math it up a little bit. Just get your brain going a little bit more this morning. Let's multiply. Okay, what would x times x be? X squared. What would I times I be? I squared. What does I squared equal? I squared equals negative 1. All of that's important when we multiply. But I'm going to start off with an easy multiplying one. We're going to start with scalar multiplication. Oh my gosh, I can't write today. So if I have something like this, 4 times negative 2 plus 3i. This one is really easy because all you're going to do with the 4 is distribute it and multiply. So you're going to end up with negative 8 plus 12i. Easy enough? Okay, now give me your full attention because we're going to math it up a little bit. If I have 2 minus I times 4 plus 3i. If these were x's, you would either FOIL or you'd use the box method. And that's exactly what we're going to do here. I'll start with FOILing this one and then I'll do the box method for the next one. So here I'd have 8, 2 times 4. Here I'll have plus 6i. Remember, just treat the I like an x. The inside 2, I'll have minus 4i. And then the last one, I'm going to have minus 3i squared. Everybody good with that? Just treat it like an x. So our next step is, I'm going to do 2 steps in one. These two are like terms, so I can combine those together. And when I combine that together, I get plus 2i. I have my 8. And what does I squared equal?
-1.
Negative 1. So this is like saying negative 3 times negative 1. What's negative 3 times negative 1? Positive 3. So this is plus 3. And now the 3 and the 8 can combine, leaving me with 11 plus 2i. And that's your answer. So when you're done multiplying, you're going to have to take, anytime you see an I squared, make it a negative 1. And basically all that does is it changes the sign that's in front of the number with the I squared. This went from minus to plus. And then just combine like terms. Easy enough? Okay, you guys try this one on your own. What does it mean if I write it like this? 3 plus 2i quantity squared. What do I do with this squared?
Just square everything.
No?
Distributed.
No? The squared means I need to write this out 2 times. And then either FOIL or do the box method. So you guys do this one, and when I show my work, I'll do the box method. So I've got an example of each. Okay, I'll put my work up here. Okay, so when I multiply together, I get 9 plus 6i plus 6i plus 4i squared. The two 6i's can combine together to be a 12i. And then this becomes a negative 1. So what does this 4 become?
-4.
Minus 4. So my final answer should be 5 plus 12i. Easy enough?
Anytime there's an I squared, it's always negative.
Negative 1. So, but if the 4 would have been negative, it would have become positive. So it just always changes the sign in front of whatever number has the I squared. Okay, last thing I'm going to show you, and we're not going to use this much until tomorrow. We're going to just quick talk about what a complex conjugate is, and then I'll let you guys go on your work. Conjugate. So complex conjugate is basically what we're going to use when we divide. Today we're not dividing, I'm just going to introduce this to you and then we'll work more with it tomorrow. But if I have 4 minus 3i, to find its complex conjugate, you change the sign only in front of the imaginary number. So if I have 4 minus 3i, its complex conjugate is 4 plus 3i.
So it's basically just the opposite.
It's just the opposite for the imaginary number. Only the imaginary number, not the real number. So the 4 didn't change its sign. Only the imaginary one changed its sign. So if I have like 1 plus I, what's this complex conjugate? 1 minus I. Okay, what about this? Let me trick you. Or try to trick you. If I have negative 5i plus 3, what's the complex conjugate? 5i plus 3, which in math land, we don't write it that way. You always want to write the imaginary part second. But only change the sign in front of the imaginary part. Okay? I don't know how much on your homework you're going to do, but tomorrow we use this. So I wanted it to be something you see for the second time tomorrow. I'm going to give you guys an assignment. I want you to work on it for the rest of class time, but you will have time tomorrow also, it's gonna be due at the end of class tomorrow. Tomorrow I have 2 examples. The math is a little more involved tomorrow, but not terrible. And then we'll go over all of it at the end of class tomorrow. I didn't write the page number down. Here are the things. I'll look up the page number. I think you'll probably get this done today, but if you don't take it home. Okay, the page number is page 128.